Hi there. In this video, we're going to be doing a Fractal Design North Pi. This is a little enclosure for the Raspberry Pi 5. 3D print all the parts yourself, assemble it yourself. So, fun little project, and the goal of this for me was to get my home server a little bit better cooling with forced air through the front. This is the first one that I built, and it shows the fans, and the fans run directly off the Pi's 5 volts, and I'll show you how to wire that. And then some extra parts for a white one that I will do later. So let's get started. Okay, so first of all, let's talk about the printed parts. If you print it directly according to the instructions, there are these two body pieces, and the fans will go into this part, the Pi goes into this part. They attach together with screws, and then there are additional panels that go on this. And it occurred to me that I'm not really sure that this split is necessary. So I combined those two parts in the slicer, and we're going to assemble this as a monolithic body. And then let's talk through some of the supports that are required here. So this part definitely requires some supports. These bridges actually would probably be okay without it, but the bits in here needed it. This is the insert that that goes into there, and that requires some supports. And then the last thing that requires supports is this is a cover for the SD card, and here's a different one, and so that fits over this little door here. And your first inclination would probably be to print it with this side against the print bed, but the problem is this gentle fillet here. And as the printer is going up, it can't do the bottom part of that fillet cleanly. So I printed it like that, and it's got some supports that you need to remove on this side. But this is the inside of the part when it's assembled, and what that gives you is a nice, clean part this way. Let me show you how to combine and slice the body part for the North Pi. I'm going to bring in this front part. I'm going to press F to select the face so that I can flip it over. And you'll see why I do that here in just a sec. And then I'm going to right click, add part, and load. And then I'm going to bring in the main body. And the main body is going to be at a weird position. But you'll see the front is 29 millimeters high. The main body is 67, and the Z position is the middle of that. So if I do 62.5 there, that is going to be the 33.5 plus the 29 millimeters. And that gets that part on top. And those two combine as one part. While I'm here, let's also do the supports real quick. So I'm going to highlight by angle, going to do, about 40, smart fill on overhangs only. I'm going to select that. Let's grab the bottom of the feet. And really, the only tough thing here that you absolutely need supports on are those to right there. I'm going to go ahead and add supports on those longer bridges. And then these ribs also are going to need just a little bit. So I'm going to take the brush. And I don't have my Space Mouse on this computer. Right, but I'm just going to add a little bit midway across the ribs. And that side's fine. I might add a little dot right there. And then that part. Okay, and that should be plenty. You don't have to fully support this bottom one. Like you could go in there and be more selective about it, but it's also fine to just select the whole thing. So now we are going to remove supports. Now I printed this with just a 0.2 millimeter distance between the support and the top. And sometimes I will use PETG as an interface layer for PLA or vice versa. But honestly, I mean, you saw how quick that came out. And this is a inside or like interior feature there. So it's totally fine. Now this one is a little bit more involved, but not really. I mean, these come out pretty quick. I should note also I use the tree supports, and I have it print or do supports from the bed only. And yeah, that comes out like just super duper easy. Okay, supports are done on that. And this one can sometimes be a little bit more messy. Oh, or not. So clean finish on the outside. Okay, for doing the heat set inserts, I'm going to be using this TS101 with a heat set insertion tool. And I think that this is the CNC Kitchen one. And I'll be using the M2 tip, and then some of these M2.5 inserts here. And these go in pretty easy. Okay, good. Just getting them, these little ones in place, can be more of the trick than actually inserting them. And I use heat set inserts in my own designs quite a lot because they're just really nice. Like, it gives you a really clean, threaded thing to insert into. And depending on how you do the design, they can take a fair bit of torque too. But only if they are pulling through the design rather than just inserted into the top like these are. So these are not good for a lot of torque, but they're good for enough torque. Apologies if this isn't super clear, but there's going to be 4 in here for the Pi to go into. And they're going to be M2.5 because that's just what fits through a PC board real easy. I tend to use M3 for mechanical designs that are, kind of on the smaller side. But for mounting a PC board, you're going to use M2.5. Okay, those 4 are done. Honestly, the biggest challenge here is with my eyesight, just figuring out which end does which. And then chasing them when you drop them. You want to be careful with these because they will be hot. Also, I should note, I set my iron a little bit lower in temperature. Like I think I've got it at 250 right now. And that is still like plenty, more than enough for putting these things into PLA. All right. Now note the amount of pressure I'm using on this is like almost nothing. Like I'm just barely applying force to get these in. The heat is doing essentially all the work. And what I'm trying to do is just get a real even pressure on it so that I'm not getting it cocked in there at a funny angle. Okay, so that's all I need on this part. Now, if you do this has 2 parts, there are some additional holes in here that you need to do. There's 4 more, but because I combined those, we're just doing the 8. Okay. There's 1 on this part. This is the interior, and sorry, like the inner frame. Again, these little M2.5s are so small, it's kind of hard to tell which end is which. Okay, great. And that's going to fit in there like that and give us a place to screw into. Okay, now I'm going to set that aside, and we're going to talk about fans here in just a moment, but I need to let the iron cool down. There's some holes in the frame, and I'm going to put some M3 socket cap screws through this side and into an insert on this side. So I'm going to use these little M3s, and these are not going to hold super well in the fan, but they'll hold good enough. I've done this before and they're okay. Now, this plastic is not PLA, so it's going to take a bit more heat to get this thing to melt and to seat in here. And I'm going to be using just a little bit more pressure too. In fact, I should probably increase the work temp on this just a bit. So I'm going to go up to 300. There we go. And I'm going to do just corner mounting on these. But I'll probably go ahead and just put all 4 inserts in. Now, if you don't want to use the M3 inserts on this, you can also just do a M3 socket cap and a nut on the other side. Yeah, now the trouble with this is that I'm also getting some melting of the plastic. So when I put the M3 screws in, I'm going to have to do a little bit of extra work to, get some of that gunk out. And I'm just going to seat this like far enough that it sticks, not so far that it's like really digging in there. There are almost certainly better ways to do this, but this is what I've done. Done. Okay, and that is really the prep I need to do on these, aside from cleaning some melted plastic out of those holes. But that will do for now. And I'm going to unplug the iron. And the next step is going to be trimming up these wires and doing a header that we can plug into the Pi's GPIO. Okay, Future Josh here. I was looking into some ways that we could vibration isolate the fans. So I showed how to hard mount the fans, but I was kind of bugged by that. These fans are pretty neat. They're RGB, but they're also higher speed, and they definitely transmit vibration into the case. So I want to use these little vibration isolating mounts to mount them into the North Pi case. Now, you've probably seen these larger type before. These are Noctua and a little bit smaller version of the same. Some more Noctua mounts. These are too big for 40 millimeter fans. I tried, and unless you do some drilling on the fans, they're just not going to work. But this actually happens to be just the right size for mounting into the case. Now, I probably can't get this to focus right, but there's 2 segments in here. There's a front part that mounts to the fan and a back part that mounts into the case. And so here's what we're going to do. We're going to put that through the hole, and then we're going to pull. And we need it, you need to pull pretty hard on these guys. And they will stretch, and then you'll feel it where it pops in, where just this little back part is remaining. And I'm going to do the corners on these. So pull that part through, and then pull a fair bit more. Okay, and it's just the back part. Front part and back part. Okay. So those are mounted. They're not going to pull out. So now for the fans. So label side is where it's going to be blowing to. So I need to make sure that that goes in the middle. I'm going to get the wires like that. Okay, cable through. And that one. That one. Okay. That one. Oh, that one. All right. And so now I'm gonna like push down on the fan and pull this, and you'll feel it where it latches in on the fan. Now, it turns out that is a lot quicker than hard mounting too. Okay, so now that that's mounted, I'm going to come in here, I'm going to clip off the excess. Okay, got some shock mounted fans. And is it going to fit? Yeah, it looks like it's just barely going to fit. So you'll see it line up in there. Okay, so that is definitely a better way to mount the fans. In terms of fan wiring, this is probably the most messy part of this thing. Because what we're going to do, the fans in here, the Pi's GPIO header is going to be about here. And so I need to trim this up, and we're going to make a header that can plug in there. And I want to take out some of this just wire length, but not so much that I don't have room for just mistakes and whatnot. So I'm gonna just wing it there, and here, let's. And then I'm going to use some of these little Molex style 1/10 of an inch or 2.54 millimeter female side crimps, and a crimping tool to do that. I'm going to split the wire. That should be enough. Gonna take a stripping tool here. This is one that's made for smaller wires. Okay, that's pretty good length. If you're not real familiar with wire crimping, this can be kind of a pain in the butt. And this is, probably won't be able to get it to focus, but I will put in the description in the comments what the model number on this is. Okay, so I have to use these kind of things for doing anything to do with wires, and I do not really know if I'm going to be able to juggle this with the camera or not, but I will do my best. So I'm gonna, okay, so one thing I could not see before is that I didn't twist these very good. And you want to have like the right amount of wire sticking out. So I'm going to twist that down, kind of trim it up just a little bit. And then I'm going to try to juggle. So for the moment, it really doesn't matter which one you do first, because putting them in the header will be a separate step. And so what we're looking for here is this part is over the insulation, and that part of the crimp, that part of the crimp there is over the wire. And this is, and then when you set these in here, I've got it. So this is a 2-jaw crimper, and this side of the crimper is doing the insulation crimp, and that side is doing the wire crimp. Getting the right depth on this is honestly kind of a as much feel as anything else, but that might also be my eyesight. And I would practice a bit first. Okay, yeah, I did not do that one right. So I did not get it in far enough, and I'm not confident that I have quite enough wire coming out. So okay, that's pretty good on the wire length. And let me set this up. Okay, that is looking proper. Gonna give these wires just a little twist, and I might trim them down just a smidge. I'm not twisting these very good anyway. Looks good. Yeah, that's also looking pretty good. Okay, now what I'm going to do before I keep going further on these guys is I'm going to get a power supply, and I'm going to give this 5 volts and make sure the fan is spinning properly. And yeah, just check out those connections before we go actually putting that into the wire harness. Okay, so I dragged my power supply over and set it for 5.1 volts and 1.5 amps. And I'm going to attach here with some little clips. Yay. Now, this fan that I'm using, I should have said this a long time ago. This is a 5-volt low-speed fan. And so the idea here is not to be moving a lot of air, but to be moving enough that the Pi's active cooler can, that you'd be just moving the hot air past it, or moving the hot air off of it, I should say. Okay, so I didn't mess up the crimping completely. That is a great sign. Now, if you don't have all these tools, well, now you've got an excuse to go buy them. Okay, so next step is going to be getting these into this is a little 2x5 Molex type header that will then plug into the Pis. We've got a couple of 5-volt pins up here, and we got a couple of ground pins. So we'll do that next. So we've got to do these little guys next. Now, there is a clip on one side of this that I'm sure is impossible to see. And it is possible when you're using the crimping tool to accidentally crimp down over the little clip part too. And I do it on JSTs all the time and it drives me crazy. So on the Pi, it's got two 5-volt pins that are right next to each other. So I'm going to do the two reds. And come. Okay. And I'm going to do this ground, which is right next to it. So 5-volt ground. And then on the other side, you're going to skip 4 and then there's another ground. So definitely look up the GPIO pinout before you do this kind of thing. I just did myself just to make sure. And this is what the finished fan assembly is going to look like. So 5-volt ground, and then skip 4 and one more ground. Okay, and let's see here, moment of truth. And we've got 2 spinning fans. Right on. Okay, so next step after this is, I guess we just need to put it all together. So let me get ready for that. Okay, now, because I'm kind of winging it here, I completely forgot one of the earlier prep steps. So there are these little bars that fit in here, and you can make these yourself out of wood, or you can print them, and they will glue into the front. And so let's glue those really quick, and then we will work on fan mounting. So I'm using some cyan acrylate, extra thick, really good for 3D printed parts. And it gives you a little bit of work time here, so I can drop all those dots down and then do this in one step. And this part kind of snugs up against the bottom here. And then while we're doing everything else, then this is going to set up. Okay. That's looking good. So I'm going to set that out of the way. And now, when we were talking about the fans here, there's a little bit of melted plastic. And so I'm going to take a M3 screw, and I'm going to clear the plastic bits out by screwing in from the same side as the heat set insert and out the other side. And so that's going to just get any little bits of melted plastic. So I'm using a M3 by 10 socket cap screw. See, just got a little bit of plastic out there. And I am intentionally using a hand driver here so that I don't accidentally put stress on the heat set inserts, because, okay, yeah, those are pretty good. Here's one. Whoops, sorry. I have found that if I use a power tool for this, I can pretty quickly yank the heat set insert out of a fan, because just where it's set into the fan's plastic is not real sturdy. It's generally fine on a 3D printed part, though, where you've got like exactly the right size hole for it. Okay, now I'm going to do this corner here, and the other holes look pretty good. Okay, that's coming all the way through on that side. Perfect. And I should have done that before wiring the fans, but, well, you know how it goes. Okay, so in terms of materials and tools here, I'm mostly going to be using a little driver here. Let's see, I'm going to need a 2.5 for my socket cap screws, and yeah, let's get those fans in there first. I discovered that an ideal fan arrangement is with the wires coming into the center. I'm not sure it actually matters that much, but now you want the side with the label facing in, so the airflow is in the direction of where the label is. So it's going to be coming in from the blank side and coming out the label side. In the hole. Into the fan. Okay, I paused the camera there for a bit because I was sufficiently embarrassed by my inability to get a screw into a fan. But just gonna keep on going here. And keep in mind, you don't need to like really anchor these down. I mean, we're talking teeny tiny fans. And also one of the fan mounting holes is going to be obstructed too. this one down in the corner. So I'm going to get enough in here and then call it good. Okay, so I've got my fans. Double check here. They are blowing from this side to that side. And I think we are now ready to, let's see, just about mount the Raspberry Pi. So the Pi's going to go in here like this. Okay, so like that. Try not to break it this time. Okay. Yeah, there we go. So really needed to scrape those channels beforehand. That's good to know. Well, would have been better to know before I broke the first one, but okay, so that's the mounting, and okay. Here are some little M2.5 screws. These are going to be a M2.5 by 6, I believe. Of course, the challenge here is going to be not dropping the screws into the case. So get that on there. Yeah. Just kind of how this goes, huh? You know what? I think I'm gonna pause the camera here, and this is getting kind of embarrassing. I need to find my tool magnetizer. Oh, okay, there it goes. Okay, and I need to use a different little screwdriver for the bottom, because my fancy one can't fit in there. And honestly, it doesn't really matter if you put these little bottom screws in or not, because it's really the top of that needs to be held. That's where the I/O ports are. Okay. So these wires, the power are going to be on the top corner here, and okay, try to make sure I line that up in the right one, and then before I screw everything down, yep, Pi starting up, fans are spinning. Super. Okay, so last couple steps here. This little SD card compartment. And just check that. Make sure those prints weren't, or the channels weren't completely chowdered. They're fine. Okay, so that goes in there. Okay, back at it the next day. And I've got this a little bit thinner panel here. I just printed it at 70% height, and that slides right in. Okay, so let's do the back panel. And for this, a M2.5 6mm countersink is going to be perfect. There we go. And don't crank these down too much, because remember that heatset inserts are, they're pretty small. Okay, got our front piece. Then one, whoops. I'm going to be fishing all kinds of stuff off the floor after this. Come. Oh, there it goes. And I think we are done. Let's power this up. So I can hear it. Once you get the fans in, also I made some little TPU feet for it. I doubt these will really do much. I was saying I can hear the fans. It's not super loud, but I can definitely hear them. It would be nice if they were PWM, but that is going to involve a bit more machinery, certainly a bit more wiring, because while you can get a PWM 5-volt 40mm fan, Noctua makes them, it's going to be just a bit more work to route the TAC and PWM signals. In fact, that might be a good next video. Okay, so what I'm going to do next is run some load on here and look at the temperature. Okay, I wanted to show you on the white one that has the RGB high-speed fans that are vibration mounted, that it looks very cool, but it is also pretty noisy. So, not sure how well that's coming through, but it's definitely too much noise for me. So it looks fantastic, and it's very good at airflow, but I wouldn't assume that those little anti-vibration mounts are enough to make a high-speed fan like actually quiet. You really need to down-regulate the speed on those fans. You could use a DC to DC converter, or you would need a like an actual PWM control using a 4-pin fan. Okay, we've had stress running for about 5 or 10 minutes now. Yep, still going. And the highest temp I'm seeing is, well, 58.2 now. So that is not stellar. It is better than the argon case I was using before. I was seeing well like into 65, 70 with the argon. Like I don't remember the model, but it wasn't their big one. But I think we are getting, some airflow through here. The fans are pretty quiet, but not silent. And it'll do for my home server. So thanks so much for watching. Fractal North Pi. Pretty neat DIY project.